Good morning. Today we are going to be talking about the number e and natural logarithms, and you're going to be looking at this packet. So hopefully you have opened up the packet and you'll work along with me on the video. I am going to work through problems 1 through 6 and then problem 1 and 7 on the back, and then your homework is going to be 2 through 6 in this first column. So after we do this video, I'm only going to ask you to do 5 problems for homework and give that to me today. Tomorrow, we're going to do another video and handout on the number e, just so that everybody is really crystal clear with it, and then that will be due tomorrow. All right, so let's start. First and foremost, what in the world is e? Okay. E is a number. It's an irrational number. And it's called Euler's number after the French mathematician Euler, who discovered this number. It is like pi. It's really used as much as pi is used. Now, you never heard of it before because pi deals with circles, and circles are shapes, and we love shapes. But e for Euler's number is used when you are compounding continuously. We've seen this number with compounding continuously as part of the PERT formula. So I'm going to actually look at that again today too. But e, as we said, is irrational. It's roughly 2.718. And e is the inverse of the natural log. So let's write that down. E is the inverse of the natural log, which on your calculator is the ln key. And if you look on your calculator, so here's my calculator right now, you'll notice the ln key has e to the x right above it. They're inverses of one another. So where does the natural log and e, how do they fit together? Where do they come from? Well, if we go back to our log, when we have our log, and we have our base, and then we have our power, and that equaled, we call this the exponent. Remember, we flip. And if I go from log form into exponent form, these are the same. This would be the base to the exponent equals the power. This isn't going to change when we deal with natural logs, and let me show you why. If I have a log, a common log, but I put a base of e, and let's just put a power of x. Let's just do that, okay? The log base e of x, this is equal to the natural log of x, because the natural log is a common log with the base of e. That's pretty important. The other thing is, if I have the natural log and I put e in here, natural log of e, which really would have an exponent of 1, let's look at this on the calculator. Now the calculator, every time you use the e, it opens up an exponent, so that's why we have to put a 1 in. So let me clear everything out, and let me type in natural log, and if I put in the e, I have to put a 1, just so that this would be the natural log of e. Now look at what happens. I just get the exponent, and that is because when we did logs, and we had the log, and we had a base, and then we had a power with an exponent, and we had this with common log. Let's say I had log base 2 and then I had 2 to the 3rd power, we were, in lesson 1, crossing these off saying this equals 3, because the base and the base cancel. We're all about the exponent. Well, look at the base and the base are going to cancel, and we're all about the exponent. So when I take the natural log of e, they're going to cancel. That makes them inverses. Now, let's go a little bit into what does like e look like. Since every time you type it in on your calculator, if you went to y equals and you put in e to the 1st power, this is an exponential function. Actually put in e to the x power. You put in e, and when the exponent opens, you put in x. You are going to get the same exponent graph you always have gotten, whether it was 2 to the x, 3 to the x, 10 to the x. Now, you're always going to go through 0, 1. You have to. This is the point 0, 1. Because even e to the 0 power is going to equal 1. But if x is 1, you are going to have this point here, which is 1 comma e. Or if you look on the table, it's going to be your 2.718. So this is a regular exponential function. And if you took these 2 points, I'll use a different color now to try to highlight. If I took this ordered pair, this x and y, 0, 1, and I switched it around and I had 1, 0, and I took 1, 2.718, and I went to 2.718, so here's 2. So let's go to 2.718 and hit 1. Now I have y equals the natural log of x. They're inverses, the same way we were inverses when we graphed all those other log problems. Now, everything that we had with logs works with natural logs. It's just instead of writing the common log, log, we're going to write ln. So let's take a look at the next thing on this page. So the next thing on this page is saying, convert between exponential and natural logs. So if I am going to convert, and I'm starting out with natural log of 4 is equal to x, the easiest way to convert on this is to remember that this natural log means the log base e, and now here's the 4 still, and here's the x still. So again, just like when we did the conversion, the base doesn't change, and it's the power and the exponent that flip. E to the x is equal to 4. And if I had this other conversion, e to the x is equal to 8, well, this would be the natural log of 8 is equal to x. From here to here would go the same way as here to here. So that's what we did. So try to practice it and see if you get comfortable with it. Let's talk about how we can use this to solve little simple equations. So, the first simple equation, number 1, natural log of x equals 10. So, we're solving now. Number 1, the natural log of x is equal to 10. And I want to find out what x is. Well, again, this is the same as the log base e of x is equal to 10. So if I want to convert, the base stays e, and the exponent and the power switch. And now I need my calculator because these are ones that you absolutely cannot do without the aid of your calculator. And I am going to type in second e to the 10th power, and I get 22,026.46579. So I get 22,026 and 46,579 hundred thousandths. That's how you say that. And if they, they didn't tell me to round, so I never round unless they tell me to round. And this one did not say to do any rounding. So let's take a look at number 2. You're going to do 5 of these for homework. So when you're doing your homework, you should go back to the video and find one that matches. That way that will help you. So now if I have the natural log of x plus 3 is equal to 6, again, this is the same as the log base e. So this would now be e to the 6th is equal to x plus 3. Now I'm going to subtract 3 from both sides. And now I have e to the 6th minus 3 is equal to x. And take out my handy dandy calculator. And I type in second e to the 6th. And I put minus 3. And I get 400.4287935. So I get 400.4287935. Again, no rounding unless you're told to round. Number 3. Number 3 has the natural log of the square root of x is equal, the square root of e is equal to x. So when I do this one, this gives me e to the x is equal now to e to the 1/2 power because invisible index of 2. Well, these sides are equal. The bases are equal, therefore the exponents are equal. Same rules apply. It looks a little crazy. Now here I didn't rewrite natural log as the log base e, so if it makes you feel better, you should write that in. This is the log of e, and that's how you got e to the x equals the power. Let's take a look at number 4. Number 4 says natural log of e equals x. Well, we just said a moment ago that the log base e means the natural log, and I have an e and an e, and they're going to cancel to the invisible exponent of 1, so 1 equals x. Number 5 has natural log of 1 equals x. Well, this is just a number. So you know what I'm going to do? I'm going to take out my calculator and I'm going to type in natural log of 1. Hit enter. And I get 0. 0 equals x. This goes along with the graph that I just erased a moment ago. Number 6 has the natural log of e to the 5th. Equals x. And again, these guys cancel. These are inverses. They cancel. The 5 drops down. 5 equals x. So that is the lesson. Now on the back is a whole bunch of homework problems. And again, the homework problems, they do get a little tough. So I'm going to work out 1 and 7. And I'm only then going to ask you to do 2 through 6. The second column, 8 through 12, you're not doing. You don't have to do. I mean, if you really, really want to challenge yourself, maybe get a bonus point or two, feel free to do the 8 through 12. But those are not being assigned to you. That I'll leave up to you.